has more data points on it. It's a simple count, so it's a bit noisier than the initial histogram. We can see that we've got an overall nice distribution tending towards normality. This is quite nice. This is probably going to be acceptable for us. We'll do some analytical t-tests on it. We can do some normality checking to confirm it. So a simple bar chart is easy to produce, but they get quite complicated when we start doing some sort of clusters. Let's have a look. Okay, go back into, say, a clustered bar chart now. We'll do a couple of them together. Oh no, I'll do a clustered bar chart. And choose define. This time though, I'm going to go for this little dialog box at the top, what the bar is actually representing. I'm not just going to do a frequency distribution like in a simple bar chart. I'm going to grab, say, total perceived stress level again, and I'm going to drop it into the variable box. For that to become active, I need to switch the little radio button from the number of cases, which is just a count, I guess, a bit like a histogram, to get it to do some more useful summaries. I'm going to go for other statistics and for total perceived stress levels in that little dialog box. What that will do is, instead of doing a frequency distribution count, it will perform an average, it will perform an arithmetical mean by default. We can change that statistically. So instead of just displaying means, I can actually display medians and lows and sums and so on. But we'll just keep it nice and simple for now. So if I just wanted to find, say, the average and do a bar chart on the means of total perceived stress levels, obviously there is only one mean total perceived stress level. It will add them all up, divided by the n, and give you one number. So when we're doing this type of bar chart, a clustered bar chart, we can start grouping things together and splitting it up. So we've got category axes and defining clusters by. So we can group them together in terms of ages and find the mean total perceived stress levels of ages, and also by gender as well when we cluster things together. It becomes a lot more complicated now. Instead of just doing a simple frequency distribution, we can do lots of things. So on my category axis, I can group it together, say, with age groups. In this piece of data, right at the bottom we've got age group 3, so it's splitting our age group variable into 3 categories. So I can drop that on the category axis. So I'll get a bar chart with means of total perceived stress level grouped together with categories. Note that the OK box is not there to be clicked on yet, because it's also asking me what do I want to group these clusters together by. And I'm going to go for the gender variable, the sex variable, and define them by that. It's only when you fill in those 3 things in a clustered bar that things become active. It makes a much nicer bar chart than a traditional bar chart. When we click OK, you'll see what we produce and how useful it is. The difference between like a number of cases kind of bar chart and a clustered bar chart. Here we've got one group together the category axis of age, and we're going to define our clusters by gender. We've got males and females. You can see the type of chart with it. We could swap them over and it would do a similar chart, or we'd have gender groups on the bottom and say 3 different bars along the key there with age. So it works quite nicely, this sort of thing. A clustered bar chart. Very simple, very nice. On the means and so on. If I wanted to do a graph bar clustered defined on a different statistic, then I could find the median values, the mode values, the standard deviations of these groups, minimum, maximum values. You name it, you could change it from that particular dialog box there. But traditionally, obviously, we want the means to make them into a useful chart like that. If you want to change the appearance of these graphs, then you need to go to something called the chart editor on SPSS 14. To do that, we double click on the chart from the output viewer, and we have the chart editor pop up. It's a horrible interface, but that's what we have. You can see it's a separate box that pops up when I double click on it. And here we can change things like the axis titles, the colours of the bars, and the axes values themselves, which is quite useful. I can click on different elements with my left-hand mouse button, and then usually I can right-click and change their properties. What I cannot do, that you can do, hopefully, is to change, say, the values of the y-axis. What I would like to do is to click on that with the left-hand mouse button to make it active, and change the right-hand mouse, change the right-hand mouse button, and choose properties. And hopefully you'll see a properties window pop up. Do you see that one? Mm-hmm. I don't see it, but you might well do. I cannot see that because I've got a low resolution monitor. It is off to the side for me. And I've tried for weeks to get it back on this computer, and I cannot. So you should be able to see that. Hopefully, one of those options on that properties window, I'll have to have a look because I cannot see it, is scale. Can you click on the scale for me? You should be able to see the scale of the axis that you clicked on. This is the important stuff. I know that you'll be able to change colours and titles. I'm not interested in that. But the scale of the axes are quite important. Hopefully it's got things like minimum and maximum values. And you can see it's got starting at 0 and ending at 30 for this particular chart. Last time we saw you, we were talking about this sort of thing, and I drew a bar chart on the whiteboard there. When we have a chart like this, it's incredibly useful because we can see that there's no real differences between the males and females, and all the total perceived stress levels of the various groups are actually quite similar. You can see that the difference between the bars is tiny. However, if we wanted to express a greater difference between the males and females, say, than there actually is, then we can change the scale of the chart, because most of it is wasted. Yes. If we change the minimum value, say, to 24 instead of 0, and then we can click click apply, and you can see that the appearances of the charts change. I cannot change that, but you can. But what happens to the appearance of your chart now? It looks like there's a massive difference, doesn't it? And as I said a couple of weeks ago, you can use your chart to basically lie about your statistics and your data. If you want to use your chart to say there's no difference between males and females, then you choose the first one. If you want to say, oh crikey, my new product is having a real difference between males and females in here, then you choose the second chart. And things like this are used in PhDs, masters, and advertising and media all the time. You have to see that difference. Normally, we've got two bar charts, and there's like a millimetre difference on a scale of 0 to 100. There's no difference between those two. But if we suddenly change the scale from 80 to 100, then suddenly the difference between the bar charts, or the difference between my hair product and the rest of the competitors' hair product, is massive. So people see that chart and say, oh crikey, there's a real difference, look at that, massive difference between those two bars. Very rarely do we look at the tiny font that is hidden away on the y-axis to display that difference, really. We can cheat with charts, and quite often, if I change the